we're going to be doing two things. We're going to look at how to determine the solubility of substances and what happens when we mix two different substances that are dissolved in solution. What happens when we mix them together? Will there be a reaction? Will there be a precipitate form? And again, we use the solubility table to determine that. Let's take a look at that. I'm going to share my screen here with you. And yeah, let's begin. You're going to want to make sure you've got your periodic table. And we're going to be looking at primarily ionic substances. In fact, that's what we're going to be looking at. Many of them with the polyatomics. And so you're going to want to have that handy right beside you. And of course, your solubility table, and not turned sideways. You're going to want it printed for you so you can use it. And the big hint, you're going to be using the top row to determine solubility. But yeah, let's get into that. In the textbook, we're in chapter 3 and specifically page 88 in chapter 3. So right there. And then there's going to be some practice questions on page 90 that we're going to want to do after we complete this video. Okay, I'm going to zoom in here. And yeah, we've got these two substances. And, you know, looking at them, they look like they're ionic. We've actually got their name here. We're going to determine whether these substances would even dissolve in water. So there's really just two things you need to do to determine if these two substances, and just one at a time, whether they dissolve in water. First of all, you're going to need the formula. And so let's write this down together. To determine solubility, you need the formula, and then you look at the solubility table. And really, it's just the top row. You use that top row to figure out whether something is soluble. But let's start with lead. And this is obviously lead 2 nitrate. I'll just call it lead nitrate just to be simple. But yeah, I'm going to get the formula out here. NO3, lead nitrate 2. Obviously, it's a solid, good ionic compound. I wonder what'll happen when we put it with water. Well, we're going to find out. We're going to check the solubility table. And the other one we're going to check is potassium chloride, KCl, classic. Again, it's the solid. And the next step after you've written them down is to look in your solubility table. So I'm just going to scroll over again, take these notes along with me here, scrolling over to the solubility table. I've got my two formulas. Now, if I want to know if this is soluble, I need to look for both of these two ions. Look for either the lead ion or the nitrate ion in the top row. Let's see if we see either lead or nitrate. Looking carefully just in the top. I don't see any lead, but I do see nitrate. And in fact, everything is soluble with nitrate. So that's definitely soluble. Well, let's do the same procedure with potassium and chlorine, or potassium and chloride. Looking on the top, do you see potassium or chloride anywhere here? Look carefully. Oh, there's chlorine. Most things are soluble, not everything though. Is potassium in this list of low solubility? No. So therefore, this is also soluble. Let's go back to that chart that we made, where we put the formula. And then we check the solubility table. And indeed, this one is soluble. And the reason, and you're going to want to put this down, anything, and it does tell you that up there on the table, anything, and do write this out, anything with nitrate. So nitrate's obviously pretty powerful in terms of solubility. Well, KCl was also soluble. And it was most things with chlorine or chloride with the Cl negative ion are soluble, and definitely this one was soluble. All right, so we know how to use the solubility table to check whether these substances individually are soluble. Can we put them in solution? What will happen when we put them into solution? Both of these would dissolve. Now we're going to look at two other substances. First of all, whether they'll dissolve. And then secondly, what happens when we mix them? When we mix them, will we get a precipitate forming? And a precipitate is going to be evidence of a chemical reaction. So let's look at two other substances here. Now this is what that evidence of a chemical reaction would look like right here. You can see there's two clear solutions. Something must be dissolved in those solutions. That can't just be water added to water, because definitely something's happened here. And this is actually evidence of a chemical reaction. Definitely a precipitate is formed here. But let's figure out if these two, and again, to figure out solubility, you need the formula, and I'll give you two substances. And then we're going to check the solubility table for each of those. And then we're going to figure out what happens when they're mixed. So this is going to be very interesting. Let's do lead nitrate again. Obviously, this is going to be lead 2 nitrate. And is it soluble? We know from above it's a solid, but what I'm going to put in here is aqueous if it's soluble. And then let's check potassium iodide. Interesting. Is it soluble? Again, if it is, I'll put AQ here because that'll mean we can dissolve it. So once you've got those two written out, look on your solubility table. Again, have them both handy right here. Let's start with the lead nitrate. Again, look for either lead or nitrate in the top row. So looking in the top row, do we see either lead or nitrate? Don't see lead up here, but I do see nitrate. Okay, so everything is soluble in nitrate. So indeed, if we had these two, if we had this one, this particular substance, it would indeed dissolve into the solution. What about potassium iodide? Again, looking up at the top here, either look for potassium or look for iodine. I don't see potassium, but I do see iodine. Okay, so this is going to dissolve. So we're going to take these two solutions. Now I'm just going to grab the right beakers here because I've got the ions. I want to put this in there and I want to put that one in that beaker. So let's just go over here. I'm going to grab these two beakers. Oh, this is going to be fun. And pull them over here for us. Obviously not in a real science lab right now. Okay, so if we put that lead into that solution, indeed it's going to dissolve. You're going to get lead ions and you're going to get nitrate ions. And same with the potassium. If we take that solid potassium iodide and put it in that solution, they're going to dissolve out. But our next question is what's going to happen when these two are put together? What we're going to do, we're going to write down the equation and a skeleton equation when we combine lead nitrate with potassium iodide. Let's write down the skeleton equation together. And again, a skeleton equation is just a summary. It just has the symbols and the proper formulas. We're not going to worry about balancing, but it is always a good idea to put the little space there so you can eventually balance this. So this solution is lead nitrate, or lead 2 nitrate, NO3, 2, and it is indeed aqueous, AQ, and we're going to combine it with a certain number of moles of potassium iodide, which is also aqueous. So far so good. We just have these two white powders dissolved into solution. We're going to mix these two together and we're going to figure out if anything happens if a precipitate forms. So what we're going to assume is what's called a double replacement reaction. Oh, that's cool. So right now, lead is partnered with nitrate and potassium is partnered with iodine. These can switch partners, and that's what happens in a double replacement. So we're going to get now lead iodide, so Pb, and of course the proper formula for lead iodide is PbI2, right? Think about the charge on lead, +2. Think about the charge on iodine, -1. And yeah, I'm not going to put aqueous yet because I wonder if this is going to form, maybe it'll form a solid. Maybe it'll be aqueous, maybe it will be. And our next one, going to switch partners, so it's not going to be with the iodine, it's going to go with the nitrate. So it's going to be potassium nitrate K NO3. Now that is aqueous, right? Because everything, nitrate, everything is soluble. So that for sure is going to be aqueous. But it's this one right here that we're wondering about. Again, let's look on our solubility table, and this is what's happening. We're going to actually pour these two together, and maybe nothing will happen, or maybe something exciting will happen. Looking for lead And iodine in the top here, again, focus on the top. Do we see any lead? No, not up here, but I do see iodine. Oh, most things are soluble. Oh, so nothing's going to happen. Oh, wait. Oh, lead, low solubility. This indeed will form a solid, will form a precipitate. And in fact, this is exactly what this reaction will look like right here. I think you might have kind of guessed that by all these pictures that I've been showing. I'll just kind of grab a copy of this, copy it, pull it down here so you've got it underneath so we can see what would happen when these two get together. Indeed, we're going to get a beautiful yellow precipitate forming. If we let this settle out, it would end up at the bottom. What's actually going to happen now, we've gotten the lead out of this solution, so that's kind of an interesting feature that can definitely be used to get lead out of a solution. So the lead has been precipitated out. And that's how to use your solubility table. Again, really just focus on the top row. Make sure you've got your formula and look for your ions in the top row. It's how we knew that lead nitrate is fully soluble. It's how we knew that potassium iodide, again, was fully soluble. But this one right here, we figured out lead iodide is indeed not soluble. And we could see that when we checked iodine, and lead has got a low solubility. And let's put it down. This is indeed a double replacement reaction, which we'll be studying in this unit. And essentially, each of these little elements have changed dance partners. And we know it's a reaction, double replacement. No, just the word replacement once, reaction. We know it's a reaction because we've definitely got evidence of a chemical reaction. We've got a color change, and we've got a precipitate or a solid forming. Now, what you're going to want to do is practice using the solubility table. So in your textbook, go to page 90. You can also review everything I've just done with you just now there. But if you go to page 90, there's some practice problems right here. And you're going to want to do questions 1, 2, 3, and 4. A reminder, all of these answers to these practice problems, they are in the Moodle site. So if you just go, you can get the answers for these. And it's a really good idea to practice that. And there's also a solubility assignment that you're going to be ready to do once you complete the practice and check it in the textbook. Okay, take care, Science 10. Have a good evening. Phil Switzer signing off.